case. But then, before we get into that, we might want to, who here knows how Bitcoin works? Like, at a high level, of course. Yeah.
What is high level?
What is high level? That's a good question, actually. So, anyone understands what happened when I get like a wallet, then I do a transaction with the wallet, and then I send money to, let's say, Joel, and the money arrives to Joel's wallet. Like basically the transaction cycle in Bitcoin. Okay. Okay, anybody knows what Bitcoin is? Like, yeah. Okay, it's a cryptocurrency, yeah. Any ideas apart from it's a cryptocurrency?
Store value.
It's a store of value, yeah. Yeah, it's a database, okay.
It's a linked list.
Huh?
It's a linked list.
It's a linked list, yes, you could say that. All right.
Can I remind say it's a peer-to-peer network?
Yes. All right, so I mean, you guys have mentioned a couple of elements, right? Like someone said Bitcoin is a database. Joel said Bitcoin is a linked list. Yeah, Bitcoin is a database of some sort, because when you think about it, right, at the end of the day, Bitcoin is like, let's say it's a technology that is used for moving value from point A to point B. Yeah.
No, I thought the database was the blockchain.
I'm coming to that. You're right, actually. Yeah. So, at a very high level, if I want to move value from point A to B, I'll use something like Bitcoin. Now, also at a very high level, essentially what it is a ledger. And the way that ledger represents itself in the technology is that it's a blockchain, which you can think of as a slow database. So it's a database that you can write to it, but you can't write to it as fast as maybe your Postgres database. Now, Joel mentioned one point. He said it's a linked list. So, well, it's not really a linked list because I guess the point he was trying to make is that the blockchain that I was talking about is like a chain of blocks. So it's almost like a linked list. So you have a block, like if you have a block here, then you have the previous block pointing to like this particular block. So it's like a glorified linked list, let's call it that way. Yeah. So the blockchain is used to store the value. So think of it like a double entry where I'm saying, okay, I'm moving Bitcoin from this person to this other person. Yeah. So then another person mentioned Bitcoin is a peer-to-peer network. So then what happens is we have a ledger, right? But then how do we keep the state of this ledger? So at the end of the day, we have like a network of computers that are communicating in a peer-to-peer fashion, and they are the ones keeping the state of the ledger. So, so your transaction is being stored on these computers, and these computers is what makes up like the Bitcoin network. Yeah, so from a very high level, that is what Bitcoin is. Any questions? before we dive in, I'm going to explain without showing like pictures or anything what happens when you make a transaction. So let's say I have a Bitcoin wallet on my phone, then I decide to send Joel money. So what will happen is I'll create a transaction and my wallet is going to connect to the Bitcoin network. So it's going to connect to one of these peer-to-peer machines and send a transaction to the network. So my wallet will actually broadcast the transaction. When the transaction reaches one of the peers on the network, it's rebroadcasted to everybody else. So the machines on the network, they keep this transaction in an in-memory database called the mempool. So the idea here is some of these machines, they actually they have the right to write to the blockchain. So what will end up happening is that they are going to put this transaction in a block. Then they are going to mine. So they're going to mine. Mining is just a way for us to say we are solving a hard computational problem. The idea is the person will win that. The person will be able to solve that computational problem. Is going to be able to write to the blockchain. So remember, it's a database. So let's say the node or the computer I sent the transaction to was able to solve this computational problem. So what they'll end up doing is they're going to write to the blockchain, and that is how I've successfully moved value from me to draw. Yeah. So the idea is I've created a new state of the world basically, where I move coin A from Vlad to Stuart. Yeah, that's why the blockchain is the state of the world, basically. All right, let's dive into it then. So today we are going to look at Bitcoin addresses, right? We are going to look at Bitcoin addresses. So I'm Vlad Kwesi on Twitter if you want to reach out. So this kind of how a Bitcoin transaction looks like. So you have inputs, which are the coins that you're trying to spend, and you have outputs. So every input in a transaction has two things. So it has a transaction ID, and it has what we call the VOUT. So the VOUT here is, so before I explain what the VOUT is, it's important for you to know what the transaction ID is. So the transaction ID here in this particular input that we have is referencing a particular coin that was created in the past in a certain transaction. Does that make sense? Yeah. So then the VOUT is literally, so you see these outputs, so here we have two of them. So the first one has an index of 0, and the second one has an index of 1. So the VOUT here is referencing the index of the output. So when I'm putting the transaction ID and the VOUT here, it's just a way for me to reference outputs from the previous transaction. Okay? All right. In truth, if you look at it in the blockchain, you wouldn't see these values. I just put these values for simplification. But in the blockchain, in the inputs, all you will see is the transaction ID and the VOUT. Yeah. Now, on the output side, the two things you would see is what we call a script pop key and the value. So, a script pop key looks like it's a cryptic kind of string that looks like this. So what it does essentially, it says that in this particular case, it says that these 7 Bitcoins I want it to only be spent by somebody who can provide me a particular public key and a particular signature. Anybody here has do you guys know what digital signatures are? You know what digital signatures are? So someone should tell us what a digital signature is. Right?
Is it like you sign something you hash a value, but it's only you can hash that value, so everyone else can verify that you don't hash the value, but you can't derive the same hash.
Yes, but let me add a little bit of content to that. So a signature, it's basically a way into. So let's step back a little bit. So in public key cryptography, right, you have your public key, which is literally the key that you can share with everyone else. Then you have your private key, which is a key that you don't want anyone to know about. Now, when you sign a message, right, what you're essentially doing is saying that if I give you that message and my public key, you can somehow prove that I own the corresponding private key. So it's like a proof of some sort, a proof of ownership of a private key. Yeah. So essentially, what will end up happening when Joel wants to spend these 7 Bitcoins, he's going to provide 2 things. He's going to provide his public key, and he's also going to provide a signature. That's how the coins are unlocked. So we lock the coins. So a script pub key is just a lock. One thing also that I didn't tell you, that every input in a transaction would have to have a key to unlock this lock. Yeah. Because if you want to spend something, you have to prove that you have authority over it. Yeah. So that's Bitcoin transactions. So let me see. So where do addresses come in actually? So that's like a good question. Where do addresses come in? So what you see here, this string, this particular string in the middle, is the hash of a public key. So we move from public key to addresses. So addresses, we basically, addresses are what we use whenever we want to transact with each other. So for example, let's say Joel was owing me like 2 Bitcoins, and I wanted him to send me 2 Bitcoins. I would open my wallet, generate like a new address, then send it to Joel. So behind that address that I just generated is a public key. So going forward, or in the next slides, our goal is really like to understand how we move from this public key to an address. Yeah. So what are addresses? So the best way to think about addresses is like they are single-use invoices. We call them single-use invoices, not really because they can't be used many times. It's because we usually advise people to use them once. Because as I said, right, we said the blockchain is it's a database. One thing we also didn't say is that that database is not encrypted. It's totally transparent. So if you end up using one distinct address for all your transactions, then somehow, let's say the FBI was to track you, they can have like they can follow your transaction from one transaction to the next. Yeah. So that's why we usually advise people to use addresses like single-use invoices. Now, we are going to go through a recipe today, which is kind of short after explaining everything I've explained. We'll start by generating like a key from your operating system. Your operating system's randomness. Then from that private key, we are going to generate a public key. Then from that particular public key, we are going to generate two kinds of public key. We are going to generate one that is compressed, and we are going to generate one that is not compressed. And from those two public keys, we will generate our addresses. Now, for people who have their computers, here is a place where I want you guys to follow along. How do I share this link?
The compression you're talking about, like, is it the normal compression or some
No.
special?
No, it's not the normal. No, it's not the normal compression. So it's not like you're compressing, let's say. Yeah, it's not like that. It's a trick, but it's called a compression.
Create a bit link.
Ah, yeah. Then where will I share it?
If you have nothing confidential, you can create a pastebin or something. Just, yeah.
I mean, the issue now is how do I share this link with everyone?
Oh,
Yeah.
yeah. I mean, like you said, maybe you can create a bit.ly.
Oh, yeah. I hope I don't have to.
You can look for an alternative one, I guess. This is just one.
Tiny URL. Alright. Okay. Is that clear, or I'll have to paste it? I'll have to zoom in a little.
Control plus, I think maybe.
Huh?
Like zoom, right?
Okay. Is that okay? Or people want to follow? You guys got it? But you're still getting it. Who is not connected? you guys all connected? You would also need this file. Give me a second. Jordan? Who doesn't have Python installed on their system? Oh, everyone does. Sure, you have Python. You have Python. You have Python. Yeah, so this is supposed to take you to a file, which is basically an implementation of the elliptic curve. I'm going to go into the details, like once we start going through the tutorial. Too much. All good? Who's not yet there? All right. Are you there? Okay, good. All right. All right. Can everyone see? So the file I just shared with you guys is this file, elliptic. So we are going to need it at some point. So one thing I didn't tell you is that in order to generate that public address, that public key that I talked about, you have to generate a private key first. That's the first step in the process. So the way we usually do it is that we generate some random bytes from the operating system, then we compress it. Let's not say we compress it, we hash it. We hash it to a certain number of bits in order to create that private key. So in this particular case, what I'll do is that I'll generate 256 bytes, Then I will hash it with SHA-256. Anyone doesn't understand what hashing means? Okay, can anyone tell us what hashing is? Joy, you know this. Alright.
Hashing came from hash browns.
Mm-hmm.
So just taking things, cutting them up together, then merging them into something smaller. And it's usually a one-way function.
Good. It's a one-way function. It takes something big, converts it into something more compact. When I say one-way function, it's just that, like, if you know the way, like we used to do. Let's say you have an x value, and you're trying to get. Let's say the hash is a function, right? So you have an x value, and you're trying to get the y value. Once you get the y value, and I give it to you, there's no way you'll be able to get back the. You'll be able to figure out what x value that y value was coming from. Is that correct? Or if you have any questions, just let me know. There are two other properties that it has, like there's a collision property, which I'm not going to go into it. It's not really important. Yeah. But then, so we'll generate those bytes. Then we hash it. The advantage of hashing is that I generated 256 bytes. Then I would hash it so that I get like 256 bits. I want 256 bits because that's what is required by the Bitcoin network. So there are different hashing functions. This particular one we are going to use is called SHA-256. It's called SHA-256 because the output is 256 bits, basically. Yeah. So one thing that I also didn't mention is that in Bitcoin, right, we use this thing called, let's see. We use this thing called an elliptic curve. We use this thing called an elliptic curve to generate these public addresses. So once I've generated my private key, the next thing I'll do is that I'm going to multiply that with the generator of this point, this curve. So when I multiply that with the generator of this curve, I'll get 2 points. And those 2 points will serve as my public key. I'm not going to go into like the elliptic curve because it's a different, like, if I start talking about the elliptic curve, then I'll most probably spend the whole time talking about the elliptic curve. Just think of it like a normal curve, but then it's used in cryptography, in elliptic curve cryptography, to like get public addresses, public keys. So once I generate that private key, which is just a number, I'll multiply it by a generator point on this curve. Then I'll get 2 points. Those will be my public keys. All right. So make sure you have the elliptic.py in the same folder as the Bitcoin addresses.py. Otherwise, Python is not going to be able to pick it up. So Bitcoin uses like an elliptic curve called SecP256K1. This is the generator point. So as I said, it has an X value and a Y value. The N here just means the number of points that we have on that particular curve. Yeah. I mean, I don't want to get into the details. The truth is that that curve I showed you is not a curve that is drawn on the real number axis. So it doesn't have like an infinite number of points. In reality, it's a curve that is drawn on like a finite field. Yeah. So that's why you have like the number of points on that curve. Now the next part is the first step is actually for us to generate randomness and hash it with the SHA-256 algorithm. So here all I'm doing is just a simple loop. I'm telling the operating system, give me 256 random bytes. Then from those 256 random bytes, which I call entropy, I'm going to hash it using SHA-256. Then I will get like a private key. Now that private key that you get is in base 66. It's a hexadecimal, sorry. So it's in base 16. Now, if I want to compare like that with the number of points I have on the curve, which is n, the whole idea is I don't want to generate a private key that is bigger than n, because n is like the maximum number you can get on the curve. So I want to generate a private key that is smaller than n. That's why you have that if loop, which basically just says that if the private key is less than n, then that means the private key satisfies the condition. So I break out of it. Now the next step is, has you guys understood the first step? Well, I know this is a little bit cryptic, some cryptography magic. Or is anyone lost? Or is everyone lost? You're lost. Yeah, okay. Are you lost? Okay. Akuma, are you lost? Yeah, okay. Right. So now the second step is basically, as I said, we have a private key and we are going to use our generator point. So we have our private key, which is just a number. The generator point is a point on the elliptic curve. So we multiply the two, then we get the public key. So this line, what it does basically, it does an elliptic curve multiply, where you multiply the generator point and the private key, then you get the public key. Now that public key, is everyone okay with step 2? So that public key is 2 points on the curve, so it's an x and y value. Now remember I said that there's a compressed public key and there's an uncompressed public key. So when you have 2 points, right? If I have an x and y value, right, and I know the function that was used to compute those points, I can basically just throw the y value and keep the x value, because I know the function. So if I know the function and I have the x value, I can always compute the y value. So that's what I mean by compression in this point. It's not like we are compressing anything. It's just that there's this nice trick. We know the function we are using and we have the x value. So there's no need for us to keep the y value around. We can basically throw the y value away, which is what we are doing in the case of the compressed public key. So on line 39, what we do is we have the uncompressed public key, which is literally the x value of our public key and the y value of our public key. But then one thing you need to pay attention to is that you realize that I'm slicing that array. I'm throwing the first two values. I'm throwing the first two values because it's a hexadecimal. And usually the way Python will represent them is that the first two characters will be 0 and x. I don't need those first two characters. That's why I'm throwing them away. Now, the 0,4 that you have at the beginning is just, let's just call it a way for us to differentiate between the public, the compressed ones and the uncompressed public keys. So we use 0,4 for uncompressed public key. Are we okay? All right. So now we've been able to generate the uncompressed public key. The next step is generating the compressed public key. Now the compressed public key, we have to, as I said, what we just do is that we throw the y value away. But then when we throw the y value away, we need to kind of keep track of, when you look at this curve, right? When you look at this curve, you can see that whenever you have an x value, you have 2 points. So we need to kind of keep track of, so if, let's say I have an x value here, I'll have a y here, and then I also have a y down here. We need to keep track of which y exactly are we talking about. And the way we do that is by figuring out whether the point, the y that we have is an even or an odd value. So if you look at the code, on line 40, essentially what I'm doing is I'm trying to figure out, okay, if the code is an even value, the prefix that I'm going to use is 02. If it's odd, I'm going to use 03. So once I have the prefix, I can now add it with the x value. Now I have my compressed public key on line 41. Yeah. Line 42 and line 43, I'm just printing it. Yeah. Now the last part is I have my public keys, but then I don't have an address. I still need to generate an address from those public keys. So the next step is generating the address. So what we are going to do is that we call this function that I wrote, is called generate base 58 format addresses. I'm going to go up to it. Anybody is familiar with base 64 encoding and what it does? You guys are all developers. I mean, front-end people, you guys use base 64 for images all the time. Then you can tell us what it is.
Encoding formats, like let's say if you want to generate like a representation, like so it's 64 because you have 26 lowercase alphabets, 26 uppercase alphabets, 9 numbers, and then 2 special characters, the plus and the slash. So what the base 64 encoding does is it takes an input string, and then it gives you an output which only uses those 64 characters. Yeah. So in this case, you want to explain that? Why is base 68 instead of 64?
Yeah, I explain that.
Yeah, okay. So go ahead.
So we took that set, that base 64 set of characters, and we removed a couple of characters from it. We removed those couple of characters because we want to generate addresses, and so that base 64 has like certain characters that can be confusing. For example, if you write capital I and you write small l, at times people cannot differentiate between the two. Or if you write, let's say, 0 and you write capital O, at times people won't be able to differentiate between the two. So what we end up doing is we take base 64 and we remove like a certain number of characters from it. So we remove like 6 characters basically. So now what is it used for? It's just a way for you to have, to represent things in a more compact way. That's the best way I'll put it. So think about it, right? Like if you were to represent 1 million as decimal, it's decimal, which is basically base 10. Now think about it if you were to represent the same thing in hexadecimal. If you represent the same thing in hexadecimal, you would use fewer characters than if you are using like decimal. So you see, like you gain like it's like a more compact. When you encode, you get like a more compact representation. That's why we do the base 58 encoding stuff. So now, how does it work? First, we have our our payload, so and a prefix. So the prefix which we are using in this case, if you go down, you can see that the prefix that we are using is 00. So the prefix or the version byte, basically what it is it tells me that, okay, I'm generating addresses for the Bitcoin main network. So I can generate the same addresses for the testnet, which is basically a staging kind of environment that we use in the Bitcoin ecosystem. So that will have like a different version byte. But since I'm generating for the Bitcoin main network is 00, that's the version byte. Now I pass in the uncompressed public key as a payload. Now, if you look at the function, what it starts by doing is that it takes the prefix and the payload and it concatenates it and hashes it. That's the first thing we do. Now, the next step is if I just hash that thing and I generated an address and gave it to you, there's a probability that one day when I'll be giving that address to Joel, I'm going to make a mistake with one of the characters. And suddenly, Joel is going to send my money to like a wrong address. So we don't want that to happen. So what we do is we generate a checksum and we add onto that hash. So the checksum is just, so you see on line 19, right? I hash the prefix and the payload. Now on line 20, I take that hash, I hash it for the second time, still using the same hashing algorithm that we used in the beginning. Now what I'm going to do is, I'm going to take the first 4 bytes of that hash. But if you realize, I'm taking the first 8 characters. I'm taking the first 8 characters is because all these values are in hexadecimal. And basically 2 hexadecimal characters are represented with 1 byte. You know why? Can anybody tell me why? 2 hexadecimal characters are represented with 1 byte.
Because anytime you select
Because?
He actually said it is 8 bits for 1 byte.
Okay. Okay, yeah, we have like 8 bits is 1 byte. But then, why do I use, why is it that to represent 2 hexadecimal characters, I need 8 bits?
1 hexadecimal is 4 bits.
Why?
You need 4 bits to represent 16 numbers.
Like, why do I need 4 bits to represent 16 numbers? To be 16? I know you know. I'm not asking.
2 to the power 4.
Yeah, 2 to the power 4, basically. Yeah. Anybody get? Did anyone? Everybody gets it, or? So basically, right? If you have 1 byte, which is just 8 bits, right? But then I was saying you need 1 byte to represent 2 characters. So what ends up happening is that each of those characters will take you 4 bytes. And that's because if you do 2 to the power 4, you get 16, which is basically the base for his hexadecimal characters. Okay? Alright. So that's why I'm doing, I said I want the first 4 bytes, but I'm taking the first 8 characters because we are in hexadecimal. So then that means the first 4 bytes is the first 8 characters. So once I get that, I do the prefix plus the payload plus the checksum. Then I call the base 58 encoding. I'm not going to go into how that happens. Basically using a Python library. Yeah. You will have to install that on your system. The Python people were following. Install base 58 as a package. Now run the code and see whether you're going to generate one compressed and one uncompressed address. Who was following?
Yeah. You can press record.
Yeah. I'm done basically. I just want to see whether somebody can run and get the addresses. Yeah. Anyone following? Have you been able to install it? Okay, so I'm going before. So, before I close, all the ramblings that I've been making, it's actually an article on my blog. It's an article on my blog called Bitcoin Addresses. It goes into like all the details. So it's just a blog article that I converted into this talk. Yeah. So if you go to my blog, vladimirfomene.com, you can get it from there. No. You have to run Python. Who else was trying to run it and has been able to run it? The address you get should start with Y. Anyway, in case anyone is interested in Bitcoin from a technical perspective, I'm just going to give you guys some quick resources very, very quickly. So there's a book called Mastering Bitcoin. It's free, it's on GitHub, so anyone can have access to it. That's like the perfect place to start. This is the book. It's called Mastering Bitcoin. And if you're looking for projects to work on and you're a JavaScript developer, I would say a very good library maybe to have a look at is this library called BitcoinJS or BitcoinJ or BitcoinJS, I think. So BitcoinJS is used for building wallets. So if you're a JavaScript person, this will be a good place to have a look at. If you are, let's say, a Rust person and you want to do some Rust with Bitcoin, there's the library I work on is written in Rust. If you want to work on the software that runs all the machines that connect the peer nodes, it's if you know some C++ and you want to have fun, this is the place to go. So this is the code that runs the Bitcoin network. This particular one that I'm showing. It's called Bitcoin Core. So it's literally the code that runs the Bitcoin network. It's written in C++. So, yeah, that's it for me. One last thing is, if you're a student and you want to get into this stuff, there's this thing called Bitcoin, Summer of Bitcoin. So it's basically an internship program where you get paid to work on one of these open source projects that I just mentioned. Yeah. All right. That's it for me. Thank you very much. Yeah. Any questions? All right.
I'll just give it and then I can give an overview of what Superbase is, what we do, and how it's linked to open source, or whether we should, it's better to give a short presentation. So just a show of hands, how many of you have contributed to open source before? How one PR, at least one, or anything like that? Anyone? Okay, there's actually quite a large crowd of you. How about on stream? Are there people oh, okay, there's no one on stream, okay? Yeah, so one of the games perhaps maybe not as low level as the Web3 stuff, Bitcoin. So today I'll just talk about, so we live in Web2, so I'll just give a brief overview of, yeah. So we're still a little bit behind on that aspect. I'm just going to live code and give a very quick demo of what Superbase is, what Superbase is about, and I think maybe after that it might be more helpful if we jump straight into the commit fest. So if everyone's okay with that, I'll just give a slightly shorter presentation. Yeah. And then if you have any questions about Superbase, you can come and ask me later. Yeah. Well, thank you everyone for coming down. My name is Joe. I work for Superbase. I am here in Nairobi just for a few things, just to check out the tech scene. I'm jumping around the various tech hubs in Africa, and then Nairobi was touted as one of the must go-to destinations within Africa, even over Lagos. Yeah. I mainly write Python, Go, TypeScript, Rust. I'm learning Rust, and my Twitter handle is over here. Not too much. So what exactly is Superbase? So everyone came here today for Open Source Day, right? So maybe it might be a bit confusing as to why there's a Bitcoin talk and a Superbase talk. Yeah. So Open Source actually is this. Just a recap. I'm sure many of you know this already. Open source is actually a philosophy that came out of the 1960s, 70s, which software written should be free and accessible to all. Free as in free to modify, so meaning you can take a piece of software, download it, and then make it modify it to however you'd like. So Bitcoin and Superbase are both examples of what we call open source projects. This means that people write code and then they just put it on GitHub. Anyone can download, anyone can use it. So what this means for practical terms is that everything I show you today, you can replicate at home. So meaning if you decide that you want to download Superbase and start your own company behind Superbase, that works out. Now, so I've just mentioned Superbase in two contexts. One, Superbase as a project. Two, Superbase as a company. So that may be a bit confusing for some. So here at Superbase, all the code we write not all, most of the code that we write is public, except for our infrastructure. This means if you wanted to run Superbase tomorrow, you could do so. Yeah. So the company actually runs hosted Superbase. So that's basically like if you think of AWS, if you think of Google Cloud, they all run like databases of infrastructure, right? You click a button and then you get an instance of like that infrastructure. At Superbase, that's very similar. We have a platform which runs, yeah, thanks so much, man. Yeah, which runs, which has an instance of our software. Yeah, so you click a button and you get everything that I'm going to show you. But concretely, what Superbase is, it's an open source Firebase. So if you've used Firebase before, it's a backend as a service. So meaning as a front-end developer, if you want to build a website, like later the example I'm going to use is Brighter Monday, I think, which is a jobs platform. Let's say if you wanted to build like Brighter Monday and then you are a front-end developer, you will need to design like the back-end mechanisms, like where do I get a database, how do I store things, things like that. As a backend as a service, we abstract away all the things that you need to do, like storage, authentication, serverless functions, and then we just make sure that you focus on just getting the design right, how it looks, how it feels, what the user experience looks like, and then we'll handle the backend stuff. Yeah. So these are the four like some of the features that Superbase offers. So Superbase is built on top of the Postgres database. So what this means is, tomorrow, if you decide Superbase is not for you, you can just take all your data and then extract it and then put it in any other Postgres database. That's completely fine because we believe that if the experience is not there, feel free to walk out. We're sure you'll come back if the experience is good enough. We have authentication. So like, let's say you want to build like a sign-in flow, like sign in with Google, sign in with GitHub. We will briefly go through like how to build something like that quickly. And then storage. So this is something like, let's say I want to build an app, right? So it's a job site. Maybe I want to store like the logos of the companies from on Brighter Monday, or I want to store like PDF files. I will put this in the storage folder. And functions could be, if I want to do if I want to add payments, I don't know why you need payments on Brighter Monday, but like, so then if I click on this button, it will trigger a payments workflow with M-Pesa, Stripe, similar, yeah. Okay, so this is just roughly how long it will take to spin up a database and go through, not so relevant. Superbase. Okay, so without further ado, I'm going to jump into the demo, which might make things a little bit more clear. So today we're going to build a initially I wanted to give a talk on how to build a SaaS, but like I think due to the time constraints, I'm just going to cover two main portions: how to use the database, how to build a sign-in flow. Now, so we'll just use this website as like an example. So the two main features are, let's say if I want to log in and I want to sign in with one of these, sign in with Google, sign in with LinkedIn, whatsoever, how would I implement it, and how would I create like one of the job listings, like any job listing. So for instance, this is my first time using the site, I'm sorry. Like let's say I want to list something like this. So so let's get started. I'm going to go to the platform. So this is our website, it's the hosted platform. So I will sign in. It's free, by the way. So like, let's say today you want to use the platform. We give you 2 free database instances. You just click create project, and you get a database for free. Heroku doesn't do that anymore. Firebase does it, but like there are lots of restrictions. But so here I'm going to create a project right now. So let me just zoom in so it's clearer. Is everyone able to see? Yeah. Cool. So I'm going to call this today, and then the region I will pick. I need to do something. I think Frankfurt is closest to here. So then I'm going to create a password. Don't do this in real life, but actually it's hidden. Yeah, so it's fine. So I've created a password. I hash. And now I have a database project which is being created. So right now, while it takes some time to set up. So while we're going to do that, I'm going to spin up a Next.js project very quickly. So what I'm going to do over here is, is just create an app. So using, well, sorry. Well, maybe not like this. Yeah, maybe. Well, basically I'm running create next app. And I'm creating a project called OSSD with Tailwind CSS. That's basically all it's doing. Yeah, well. Oops, I may have accidentally. Okay, so I'm creating this app and then it's downloading, it will take some time. And meanwhile, so I have this platform. This is the Superbase platform, which you can make use of. So like I mentioned, this is open source. If you wanted to, you can, I'll show you how to go to the repository. Theoretically, if you wanted to, you could download and host it as well. Yeah, so right now, right, so we are a job platform, right? We are building Brighter Monday. So we need to create like some way to list jobs, I guess. So I'm going to go to the database tab to create a table which can house the potential jobs and like roles that we might want to have. So this table is going to be called jobs, I guess, because and then job listings, right? Because because we want to show jobs. And then we'll create some columns over here. This is not going to be very realistic, so but just bear with me. So like, I think maybe you want like a title, right? Well, yeah. And then this will be a text field. So this will be, or maybe description. So this is like how you would describe the job. Like maybe it's software engineering. Well, sorry, title is better. I'm a software engineer at I don't know, Wasoko, or like I want to apply for the role of a manager at iHub. Yeah, so then this would be that, and then we would also have, say, I don't know, probably salary, and then in KSH, and then let's say, yeah, default, no salary. Yeah, and then we just create a table with just title and salary for now. I'm sure there are more important things, but maybe like the requirements to apply. But let's go with this for now, and then let's create these 4 columns. Okay, so now we have a table of jobs, right? So then let's insert some rows into our table. So let's go to the table editor. Right, so this table editor that we have allows you to view all the rows in the table. Right, so here we see that just now we added the ID, the created ad, the title, and the salary. And then, so here the ID is automatically generated, so we don't worry about that. Created ad is filled in by, so the title is probably what's important. So let's say I am a manager at iHub. And then, for a manager at iHub, maybe the monthly salary is like, I don't know, 4 million KSH, right? But probably not true, but like, yeah, we'll just give an example. So we have this manager at iHub, and that's one row. And then maybe another row might be, I want to be a software engineer at Superbase. And here, maybe we make less, so like we just put in a number, 500K. So then we have these 2 rows, right? So this is within our database. So let's try and see if our project has been set up, and we can actually extract the rows. First let's confirm that our website is working as expected, and then after that, let's try and retrieve data from our database so that we can show the job listings. So I forgot about this. We do actually need to wait until we're done installing. And then, so now let's run. And then first let's check that the template is working fine, right? So it's a bit small. We have a Next.js site, maybe familiar to some of you. So let's edit from here. So, oops. I'm not going to make that many code changes, so hopefully that will be fine. Okay, so right now I'm in another project, and then I'm going to OSS day, and then I'm going to go to pages, and I'm going to go to index.tsx. Now, because maybe it's ideal to simplify things, let's just delete everything first, and then think about it later. Right? So right now we delete everything, and let's just say as OSS day. Okay, so then let's save and refresh, and then we see that OSS day is indeed shown on the screen, right? So all that is good, but so we haven't used any Superbase yet. So Superbase actually has a client library which allows you to interact with what I have shown you over there. So we just need to initialize it, and how I'm going to do that is to create a utils folder, and then with superbase.tsx. So this is just a TypeScript file, and then we will populate the file with some variables. Superbase equals to, sorry, before that, I actually need to install the Superbase client first. So let's just stop this and install the client. And while that's installing, it's not Python. Yeah. I don't write that much JavaScript, so bear with me. So then we import this helper function to help us create a client, and then we say export before Superbase, and then const Superbase equals to create client. Wait, this is sorry, I should explain. I also maintain the Python library, which for Superbase, which has a different syntax. So I do need to look at docs. So yeah, okay, yeah. So right. Before that, let me just so then this would be the URL and the secret key. So the URL refers to the website, the URL instance of the Superbase project that we're using. So in this case, the project would be a link with the unique reference. So I'm going to show you where you might be able to find that. So that's under settings. And then we are going to go to API. And then you see that you have a dedicated project URL and a project API key. And this is so that not just any generic person, like any person on the street, can access your project. This key is to ensure that, hey, I am who I say I'm who I claim to be because I have this secret, right? So we have this URL. We can paste it here, but generally people recommend that we paste it in environment file. So then we're just going to create a file called .env.local. So I think this is the convention. So we create an environment variable file with next public Superbase URL and next public Superbase key. This is just to store the variables, and next public is just a prefix to allow Next.js to expose these variables. Oops. So I'm copying the API key right now, and right now let's check if let's go back to the utils folder, and then wait, sorry.
Next.
Okay. There's the environment variable, right? So, 1 second. Sorry. Process.m. Yeah, that's right. Yeah. Thanks. Yeah. Superbase key and the Superbase URL, and I think I may have the order swapped. Okay, so now we have a client initialized, so that may have taken a while, sorry about that. So then we go back to index and then we say, we import the Superbase instance that we have initialized. Utils / Superbase. And then we see if the client is successfully initialized by doing just a console log, I guess. And what's there? Okay. Well. Oops. Okay, sorry. The definitions of it off. Emitter type string. Okay, let's see what I define the URL to be. It's probably Superbase URL. It's probably Superbase key. That's right. Yeah. Sorry? Typo? Okay, thanks. Yeah, can get a bit tricky. Thanks for that. Okay, so we see that it's currently not defined. Let's see what's going on. Yeah, okay, so now we have a Superbase client, and then you see that this client is initialized with all the functions and variables. Yeah, so now let's make use of this Superbase client to actually get records from the jobs table. So let's do that by doing a query to get the jobs. Sorry. Maybe in a use effect. Oh well, let's do this. Sorry, I need to check the docs. Get static props, and then we want to return, I think, the jobs table. Okay, never mind. Let me just not do the server-side rendering. I'm sorry, and then try and get the jobs records to fetch. So right now I'm going to say that I'm going to fetch from the table, which is called jobs, dot select. So this is a bit like SQL, star. And then we say const data, and then we call this jobs. And then console.log, there's a copy error, let me just extend a bit. Data does not exist. Dot execute, I think. Yeah, should give it. Okay, so then let me just refresh that. Okay, the syntax is slightly different for JavaScript. Right, sorry, my bad. Okay. Yeah. Don't select. And I think I'm missing it. Sorry. Okay. Sorry about this, 1 second. Okay. Let me check the table name just to make sure that I haven't accidentally. Okay, no, that's right. Sorry, this is. Yeah. Okay, so yeah, this makes sense. Where's my button? Oh, didn't it? Yeah, okay, so then, so just now it probably wasn't working because it was not made by an async call. So over here we see that we're able to, I created a button as a hacky workaround just to get async call, and then we can see that we are fetching the data from the database, and then now we can attempt to render it. I'm not sure if this works. I know I did it, but let me try. and then the syntax for this. Oops. Yeah. Okay, this is actually not a great example, but bear with me. Sorry. New state, I think. Yeah, and then she calls this. Does this work? I think. Then in this case, this needs to go in. And this should be well, I technically need to type this, which I think, sorry? Well, maybe I'll just leave it the button right now, due to time constraints. But yeah, that's roughly how you would fetch data. And then the next thing I'm going to walk through is probably an auth flow. So like, basically where I was going to go from here is to just get that into an object, and then just make sure it displays on the page so you can see all the jobs. The next thing that I'm probably going to walk through is how to set up like an authentication flow. So this is how to build like a sign in with Google page or sign in with whatsoever. Well, actually, let's just leave it there. Leave it loosely fair. Set jobs. Cool. So yeah, in order to do like authentication, we need two things. One is to be able to sign in, and the other is to be able to sign out. Yeah. So in order to do so, we first need to define a method that we want to sign in by. So in this case, for simplicity, I'm going to make use of GitHub sign-ins. Yeah, because most developers would have GitHub. So in order to set up a GitHub sign-in flow, what I'm going to do is actually first generate. So sign in with GitHub uses this protocol called OAuth2, and OAuth2 means that you would request for permissions from an external entity, so in like Google, GitHub, Facebook, whatsoever, and you would create a client so that you can actually ask GitHub, Facebook, or Google for the relevant information, and then GitHub, Facebook, or Google will send the information back to your application and say, yes, this person is who he or she or they claim to be. Yeah. So right now, what we're going to do is create a OAuth2 application, and I'll just show how to do sign in with GitHub from there, and then after that we wrap up. Yeah. So yeah, so I'm going to create an OAuth app right here. So then that is, this is OSSD, and then the homepage URL is this. And then for the callback URL, so the callback URL is where the, so you're making a request to an external application like GitHub, Facebook, or Google, but they need to tell you like the relevant information about the user, right? So you need to give them a callback URL through which they can tell you, oh, this is the user's relevant details, and so on and so forth. Have they verified their email? Yeah, so I'm gonna just configure it right now. So here we have the authentication settings page. And then under GitHub, I will just enable GitHub, and we'll see that we need a client ID and a client secret. So I'm gonna get this right now. But first, yeah, I was gonna get the callback URL. So the callback URL is just right here. And then after registering that, I'm just going to copy and paste these two things. And then I'm going to generate a client secret. I'll delete this later, so yeah. Again, not the best idea to do this while on live stream, but
It's okay.
yeah.
It's blocked.
Yeah.
See, you can do that with the letter.
Sorry?
You can do that with the letter.
With the what?
With the JS letter.
Yeah, you can.
Um,
You need to set up the authentication mechanism first before you can use it with the JS library. You are perfectly correct, yeah. So after I do this, I'm going to use the JS library to do that. So here we save, and then we have the credentials for a GitHub wall of app. So now I'm going to trigger a sign in. So then again, I'm going to do this via another button. By the way, if you're writing an actual SaaS app, do implement proper error handling. Yeah. Sign in. Okay, and then I'm going to say sign in with GitHub. And then again, I'm somewhat guessing here. I will need to check the syntax. So all this is readily documented on our website. It's just that I am, and then normally at this point you will want to redirect the user to a separate page, but since we are trying to wrap up, 1 second, sorry. Sorry?
Is it signing with provider?
Yeah, signing with provider. That's in JSV. So right now what I'm using is the version 1 version of Superbase. So Fatima is quite right. We are going to upgrade on Tuesday, which will change a lot of things. Yeah. So actually, I should use my own document, the documentation that I wrote. So I and I don't think you need double quotes in JS. So yeah, that should work out. And then right now, I'm going to trigger a sign-in flow. And then you can see that it's redirecting, and then I can implement a sign-in, and then I can click authorize, and I'm redirected back with, and now I'm signed in. Yeah, so that's roughly how the sign-in flow works. Yeah, thank you everyone for your time. Yeah. Any questions? Yeah. Yes?
So, like, I'm kind of curious also for these ones. So,
Yeah.
like, do you compile PQ to Wasm or something?
Oh, that's a good question. We actually do have a compiled version of Postgres to Wasm. So Wasm is WebAssembly, so it's something that allows you to run code in the browser. We don't. We actually have a server running on AWS somewhere. But we do have a prototype version of that which does run in Wasm. So I can look it up. Superbase. So again, this is also open source, by the way. So if you want to contribute to this repo, you can. So this is our version of Postgres running in the browser. So normally you need like your database will be running in a separate instance. But in this case, what like some of the team have done with another company called Snaplet is to actually write a version of Postgres, the database, that can be compiled into WASM, WebAssembly, that can be run in the browser. Yeah. Yep.
So I'm assuming like all these front-end connections are connected to Postgres.
Yes.
So like the
yeah.
come with a cooler built-in.
Exactly. Yeah. So that's also a good question. So like it doesn't directly connect to Postgres. It's behind. It connects to an API gateway, which then connects to Postgres. But yes, we have a connection pooler. We use PG Bouncer. Yeah. Any other questions? Yes.
You say that Superbase is a database.
Yes.
So can I store my data
Yes.
and use it in another data pipeline?
Yes. Exactly. You can. Yeah. So like how you would do this is so it's exactly the same as you would with so how many people here are familiar with like Postgres or like any other database? Yeah. Okay, that's a few. So like you can do what you would do with like a Postgres database. So like what you may be familiar with Postgres database is to use T-SQL, right, to connect to the database. So you can do the exact same thing. We have a connection string here, and then you can go to the database, and then you do this. And sorry, password. The password is wrong, but yeah, basically you can connect. I hope I didn't forget the password. Let me try again. Sorry. Yeah, okay, that was right. So then you get like a typical Postgres database. It's nothing but Postgres.
One last question.
Yeah, go ahead.
If I store my data in
Yes.
Superbase,
Yes.
I can access it. It will stay there for any long time without being paused.
Yeah, whatever you want. Well, so one thing to note is that we do have like a 7-day pause period. So after 7 days, we'll take a snapshot of your data and then we'll just pause it there. Because it looks like you're not using the project, right? There's no point in wasting like resources. But if you're actively using the project, like let's say you are making queries every day, yes, you can theoretically use it for however long you want. Yeah, question.
When are you guys supporting new SQL?
Oh, yeah. So I don't think that's in the pipeline anytime soon. But yeah, you can. Yeah, sorry. Yeah, you can import from NoSQL to us to Superbase. So we do have like I think an exporter somewhere from MongoDB or similar to Superbase. Yeah. Question.
So can you talk about any Postgres compatible database or just specifically vanilla Postgres?
No, that's a great question as well. So right now you can get it to work with RDS, but you need to make like Postgres compatible databases, but you need to make some configuration. So generally we would recommend that you just use Postgres, but if you really wanted to for some reason, yeah, you probably could. Yeah. One other thing to add is that Superbase is a fully remote company. So what that means is we have people all across the globe, and we hire all across the globe, and we don't discriminate based on, well, not discriminate, we don't distinguish between compensation for whether or not you live in the US, or you live in Nairobi, or you live elsewhere. It's all the same. Yeah, so that may be a pro or a con depending on where you live. And also sorry, I forgot to show this. So it's open source, right, I mentioned. So all our source code is right here. So Superbase/Superbase. So theoretically, if you wanted to, you can download this today and run your own instance of our website. Yeah. Yeah, and I mentioned that we are fully remote, right? So last month I said we weren't hiring, but actually I checked and we are hiring, but like for a separate set of roles. If you're interested in like a support engineering role or contributing to Postgres, feel free to reach out. Applications are a little competitive though. On average, we receive about 200 to 300 applications per role. But yeah, nonetheless, please do apply if interested. Any other questions?
I have a particular question.
Yes.
So why should I choose Superbase instead of Postgres?
Yes, exactly. Great question. So like, why should you use Superbase over like vanilla Postgres, right? So there are a few reasons why you might want to do that. Yes, of course, you can use Postgres. but one is like hosting. Like if you use vanilla Postgres, you need to manage that on your own. Most of the time, this entails like if you're an enterprise, if you're a company, because with one database you can store like maybe a few like gigabytes, terabytes with stretching in. But as you scale, you need to like distribute data over multiple databases, right? You can do that alone if you want to, but like you won't get the availability and scalability guarantees that you'll get on hosting of our platform. Two is because of all the other goodies that we offer. So like Postgres has this thing called row-level security. So that's something that spreads across like all our products. So like let's say if you use the authentication system, and then you want to define a claim or a role. Like let's say so like the job site example, right? I am an admin, right? And then you want to say that only admins can perform certain actions on the platform. This admin definition will spread across all the services that we have. And that's something you don't quite get because when you want to build a SaaS, right? Like let's say you're someone looking to create a startup, you won't just need Postgres, which is the database. You also need all the other functions like storage, authentication, yeah. Oh, but sorry, go ahead, yeah.
So we talked about scalability.
Yes.
So how does Synapse scale? From this information around Postgres.
Yes. That's a good question as well. So we have a few ways of like managing the scalability. One is horizontal scaling, the other is vertical scaling, right? So like in terms of like, horizontal scaling meaning that, vertical scaling meaning that we have a larger database. Like so, let's say you use like 5 gigabytes, I don't know. Then I now want like 100 gigabytes, so then I upgrade to a 200 gigabyte database. That will be like horizontal. And then we have like vertical scaling, horizontal scaling, which is like I have many databases. So like if I have like 500 gigabytes of data, maybe I can distribute it such that like I have 100 here, 100 there. So that's like a scaling strategy. But like internally, what we do as well is like we have connection poolers, like was mentioned. We have an API gateway. We have various other mechanisms. I'm not on the infra team. Well, I do touch the infra, but I'm not on the pure infra team. So that's as much as I can tell you. The rest of it is detailed on our website. You can check out the docs. Yeah.
What do you use for horizontal scaling?
Sorry?
What do you use for horizontal scaling?
Oh, horizontal scaling. We just use read replicas. Yeah. It's just built in.
So no sharding?
Sorry?
No sharding?
Yeah. I mean, no sharding yet. You could if you wanted to. Yeah. Yeah.
Since OpenSource is not entirely free,
Yes.
if you have a million of services,
Yeah.
you pay at all.
Well, so by working for the company, the maintainers, like, so we hire our maintainers. So that's one possible reason why you might want to contribute to open source. So like, the first hire for this company was actually the maintainer of the underlying, one of Postgres, one of the underlying technologies. So what Postgres does is it exposes Postgres as a REST API. So like previously, like you can make REST API calls. So the maintainer was like working in out of Peru, and then like I think he was just like bootstrapping like the way like people do like on open collective donations, and then they ended up hiring him. Actually, we hired like a significant number of this is a stretch, but I would say at least 50% of the company maintains at least 2 open source projects. Yeah. Don't quote me on that, but I think that should be roughly accurate.
Last one.
Yeah.
So use Apache.
The license?
Yeah.
I think it's MIT license. Yeah.
MIT.
Yeah.
So like, have there been any hostile forks of Superbase?
Well, not. I mean, people do copy it. We actually encourage it. We encourage people do copy our website. They do copy self-hosted database. We encourage it. Yeah. I mean, it's all fine because ultimately, like, what differentiates an open source platform is not the like based on the model we're running at least, it's not whether or not you have like you can copy the platform. Sure, it's about like being able to copy the guarantees, like the scalability, the availability that we mentioned. Like, yeah. So far it's been okay. But I mean, if you're referring to like things like Mongo and the BSL license, we haven't had to deal with anything like that. If AWS comes along, we'll see how that goes. Yeah.
So long term you're committing to.
Yeah, we're not changing licenses. Any other questions? Oh, and of course, how to get started contributing. Yeah, just you can go over to our repo. We have a bunch of. Oh, and I should probably highlight, we do have a few contributors from Nairobi. Fatuma is one of them. Yeah, she contributes to our Flutter library. So, yeah, any questions you can reach out. Yeah, we're also generally on Discord. So if you have anything over there, you can jump onto our Superbase Discord and yeah, or just tweet us. I mean, if you tweet the CEO, he will reply. Yeah. So
The CEO will reply.
yeah, Paul Copplestone and Anthony Wilson. Yeah. Thank you, everyone. Yeah, reach out if you have any other questions.
Yeah, so for the interest of time, I'm just gonna zoom past this slide. So this is our walkthrough on how you can contribute to your open source projects this Hacktoberfest. Yeah. So initially, ask yourself why would you participate in open source? So these are two of my reasons why I participate in open source, particularly Hacktoberfest right now. There's a lot of projects going on, and one of them is to get some experience, because nobody wants to hire you when you don't have experience. And yeah, you also get some confidence to deal with your imposter syndrome and stuff. So I have an article on that that goes in depth on how to use experience and confidence for your career. So somebody might ask how do you get these open source projects? The biggest hurdle right now is finding those projects. You find that there's a lot of projects right now going with the Oktoberfest tag. So I've come up with a way you can use to get these projects. So it's super simple. You just you put these URLs, and don't worry, I'll share these slides after the presentation. So yeah, just put in a good, that's if you are a complete beginner to open source contribution. So you put in good first issue and Hacktoberfest. So with the Hacktoberfest label, you get an entry to get swag. So 4 valid pull requests which are merged or accepted, you are in for a treat at the end of Hacktoberfest. So the particular workflow that has worked for me and many throughout Hacktoberfest for open source contribution in general is claim it, fork it, work it, do it. You can create a song out of it. Claim it, fork it, work it, do it. Then claim it, fork it, work it, do it. Push it, sorry. I'm confusing. Yeah. So the first step is to claim an issue. It's good for maintainers and staff to make it easier for them to supervise how things are going. So if you just jump into a project and you don't claim it, there's a high chance of it being rejected. So that's why you should claim a project first. You should claim an issue first before jumping into working on it. Yeah. So after the maintainer has approved your pull request, it's now time to fork the project. So after you've been assigned the task, you fork the repo to your local GitHub instance. So I assume you're using GitHub for this presentation. There's GitLab, there's Bitbucket, and there's another one, I don't know which one. Yeah. So now it's the time to work on it. So you just implement the feature. So after you have your local fork instance, you clone to your local development instance, and then you create a branch. So branching has been improved to minimize a lot of merge conflicts, yeah. So if you, rule of thumb is that, like when you work with branches, it minimizes a lot of merge conflicts with projects. So yeah, so after you have your branch in place, you use that opportunity to like work on the feature, and yeah. Okay, now so you've done working on the requested feature. Some of the workflows involved include like adding the changes that you have done to the project, writing a descriptive commit message, and then pushing it to the auditing. But as a branch, as the branch that you're working with on your local instance. Yeah. So yeah, you're an open source contributor. That is, there's no trial, there's no like funny business, there's no magic. It's that easy. So yeah, I think that's my presentation. I don't know if anyone wants a demo. Anyone? Demo. I can see laptop. Demo. Yeah, that's my presentation. So maybe one last thing. I have some projects that, some local projects that you can start with as I bring the screen here. Yeah. So one of them is the WebCon KE Android application. If you are doing some Kotlin, they are looking for contributions for their conference application. So this is their organization repository. We also have still on the WebCon KE organization, we have their React Native application. An instance of their conference application is React Native. So yeah, contributions are also welcome. Small caveat, I'm also one of the maintainers here, so if you don't follow my workflow and reject it, I will definitely ask. Yeah. So we also have, still on the WebCon KE organization, we have the web implementation. So if you work with the TypeScript, yeah, you can keep your shot and talk nicely to the organization, maintainers, and then give you a shot. Yeah, still on WebCon is our Flutter application. If you're good with Flutter, you can keep your shots. Yeah, we have Open Source Community Africa Nairobi. So this is a branch of OSCA, which has a presence in Nairobi. So they post a lot of challenges dealing with open source contribution. So this is a worthy repository to give a shout out to. And then if you're into Golang, we have a Go organization with some projects. So you can be checking at it from time to time to get some projects that they work on. And then if you are into React.js development, we have an organization that we host a number of projects. The main one right now for Hacktoberfest will be our official community website. So you can use this opportunity to contribute to creating the community website. And yeah, looking forward to your pull requests and your contribution. So I think that's it from my side. If there's any questions, comments, yeah. Yeah. Questions, comments, suggestions. Professor,
if there's anyone doing Swift or Kotlin, the library I work on, which is written in Rust, it has so we ported it to all those languages using foreign function interface. So we only contribute to that.
Yeah. So in case anyone wants to plug in, I can see candidates, can see delegates from a lot of communities. So this is the time. Yeah. Yeah. Yes. So immediately after this event, there are some issues that are going live. Yeah, so it's in real time. So once you get to your laptop, you'll have some issues to work on. Once you get to your laptop. Yeah. So I think that's my presentation. Happy October. Yeah. Yeah. So I think the number one maybe bottleneck was not defining like the roles for each stage of the process. So initially we wanted to like have open source design and open source development. So the design was like a drag for the project during that time frame, but we had a workaround where we got some like can I say new designers who like implemented it in record time, which also made it easier to transition with the issue, like creating issues and implementing the system and stuff. Yeah, and also initially I thought TypeScript would be a bottleneck to like beginners, but the project didn't receive as mainly beginners. So maybe something for the future is like if you are supposed to start with TypeScript, just start with it. You get people who are maybe beginners in TypeScript to take it up. Yeah. To answer your question, I think there's another one. Okay, what's the second? Yeah. Questions, comments? Yeah, so my team number is yeah, I'm done.
I just wanted to add one thing, which is that, like if you're looking for a job, and you're thinking of like working at one of the big companies, you have to like get a good pay. I think one of the things that we didn't have in the past is like companies that were at the same time profitable and doing open source. It's very easy for you today to just prove yourself by doing some proof of work on one or two of these repositories. Then at the end of the day, you get noticed by someone eventually. I'm sure if